A function is a rule that assigns each input value exactly one output. Okay. And a function rule, same page, it's also highlighted. What does it say about a function rule? What does it say? Bless you.
It's an equation that describes a function.
Thank you. Sorry, guys. I'm gonna get better at all this, I swear. Okay. So these came right from your book. So we're going to talk about what they mean. So a function is like a machine, a math machine, like a calculator. And when you put whatever operations into it, there's an unknown, right? Like a variable. And that unknown, whatever you do, as long as it's the same thing and it's true math, you'll always only get one answer, right? So like if you start with 12 and you add something to it or subtract something to it and then divide, let's say you get 3. If I put 12 in again and do the exact same thing, the exact same function, I'm always going to get 3. Does that make sense? If you do the same math over and over, the answers don't change. If you put in 12, you'll always get one answer. That's what a function is, okay? So, we're gonna practice with some tables today, some input and output tables, as well as some equations that are functions. So, any questions? So far, so good? All right, let's try it. If we have an example where, this is from your book on the bottom, this is the quick check number 1. The function of f equals 9/5 c plus 32. And this formula converts the degrees in Celsius to the degrees in Fahrenheit. So we're going to evaluate the function, that means solve, for c equals 20. So if it's 20 degrees Celsius, what is it Fahrenheit? Right? In the United States, we're like the only people that do Fahrenheit, right? So everywhere else in the world, they're talking Celsius when it comes to temperature, and then there's us. So we need this formula so that we can convert to temperatures that make sense to us. So let's plug it in. This is our input number. It's what we're inputting into the equation. Okay? So I'm going to rewrite it. F Fahrenheit equals 9/5 times 20 plus 32. What's the first thing I'm going to do to solve? What's the first thing?
Do the thing in the parentheses.
Yeah, always start with parentheses, right? So this is going to be multiplying. And I'm just going to do it off to the side because I like a nice clean, right, when I'm working my way down. So if I take 9/5 and I'm multiplying that by 20 over 1, I can simplify 5 and 20 because 5 goes into itself once and 5 goes into 24 times. And then I just have 9 times 4, which is easy math. So now over here I have F equals, and what is 9 times 4? 36. And then I just can bring down the second part, plus 32. Okay? And now I'm going to add these two, and I get, what is 36 plus 32? 68, thank you. 68 degrees Fahrenheit. Chilly. So 20 degrees Celsius is chilly. Any questions on this? So this answer is an example of the output. Every time we put in 20, we're always going to get 68. In order to get a different number for Fahrenheit, we need a different input number. Any questions on that? Great, let's do another example. Dude, I'm not boring. Yawning at me.
Come on, Jackson.
Sheldon, you would never do that. Okay, here we go. This is example 2, and it's of a table. It's of a table. Example 2 says T equals 1/2 m minus 12. It's talking about temperature in a container where m is minutes, right? This is like for an experiment, okay? This story is fine, but we don't need to focus on that. We need to focus on the math. And they're telling us for m, they want us to use, so for the last one, we just had one input number. This time, because it's going to be a table, they're going to give us 1, 2, 3, 4, 5 numbers. Are we okay back there? -2. Then we're going to use -1, then 0, then 1, then 2. Okay? So 5 different numbers. So because we're going to have 5 different inputs in our table, that means we're going to have 5 different outputs, answers. Okay? You guys with me? So I'm going to make my table. I have no idea what these things stand for, but M was given to me in the problem, so I'm going to put M on the left as my input. And then T is also in my problem. So, and T is after the equal sign, so that's my answer, right? My output. So I'm going to put that on the other side. And then to build my table, I'm going to use the numbers that were given to me. So I'm just going to start with the same order. So -2, then -1, then 0, then 1 and 2. Okay, so now I have to do the math. T equals 1/2 m minus 12. This is going to change 5 times. I'm going to do this problem 5 times. I can feel the excitement radiating off of you. So the first time, T equals 1/2 times -2 minus 12. So I've plugged in my first number, which is -2. If I make it over 1, just so it looks like a fraction, focus if you can. 2 goes into itself once, 2 goes into -2 -1 time. So I have 1 times -1, 1 times 1. So now if I clean it up, I have T equals -1 minus 12. And what is -1 minus 12? -13, right? When the signs are the same, we add them. So I can put that as my output. My answer, when I plugged in -2, my answer was -13. So it's 5 times, but it's not hard math, right? We can handle this, okay? So now I'm going to do it again. T equals 1/2, this time times -1 over 1, and then minus 12. Got to keep everything else the same, okay? So this time I can't cancel anything out. I just have a lot of 1s with a negative. So when I clean it up, I have T equals -1/2 minus 12. So again, my signs are the same, which means I'm combining. So what is -1/2 and -12? -12.5. So that's my output. I'm just gonna write 0.5 for my table to try to keep it a little cleaner so you guys can see. Next up, 0. My next number is 0 to plug in. So t equals 1/2 times 0 minus 12. Okay, so everything times 0 is 0, so I have t equals negative 12. Right, anything times 0 is 0, so I just have negative 12, so I can throw that right into my table. Next up, t equals 1/2 times, my next number is 1 minus 12. When I clean it up, I have 1/2 and then minus 12, but 1 is positive this time and 1 is negative. So what does that mean I need to do? When the signs are different, what do I do? Anybody? Hello? It's like I'm back on the videos. Is anybody there? The bigger one is going to be the sign for my answer, right? So 12 is bigger, and it's negative, so my answer is going to be negative. And when they're opposite signs, we subtract them. So if I take 1/2 away from 12, what do I get? 11.5. So I have negative 11.5. So that's my output. So I'm going to put that in my table. And then for the last one, I have a 2, a positive 2. So the last time I'll be solving this problem, 1/2 times 2 over 1 minus 12. The 2's cancel out, the 1's cancel out. T equals 1, positive 1, minus 12, which is 11. Okay? So now my table is complete. You will notice that there are 5 answers in this table. So this table will be worth 5 points. And on a quiz, every section of work will be with a point. So these will be worth 10 points. So if you show me all the answers but no work, you'll get 5, which is half credit. 50% is an F. So show me your work. Any questions? How are we doing with this? Great, so thanks. So next, I would ask you to do your whiteboards, which I know we don't have markers for. So in your notes, you're gonna try one for me. We're gonna do an input table.
If you have an extra marker, can you do one?
Yeah, do it. Here is your problem. The function is 3 plus n. Nice and easy. 3 plus n. And your numbers are going to be 0 when n equals 0, 1, 2, and 3. This is your you try. Okay? So you're going to make a table. We have, in this problem, we have an n and we have an f. The n is the input because that's the number that's changing. The f is the answer because it's alone on the equal sign. So if you guys could fill this in, try to do that as best you can. Remember, the n's are given to you. So those just go straight into your table. And then you plug them in to show your work, to solve for your f's.